Okay, let's take a look at this break-even volume and pricing problem. This is problem 9-22. Dimwit is the county commissioner of Clueless County. He decided to institute tolls for local ferryboat passengers. After the tolls had been in effect for 4 months, Astra Astute, county accountant, noticed that collecting $1,450 in tolls incurred a daily cost of $1,800. The toll is 50 cents per passenger, and we're going to answer these 5 questions. Okay, first question is how many people are using the ferry boats each day? And what we know is our daily tolls are totaling $14.50, and the cost per passenger is 50 cents, right? I'll just enter it as 0.5. So the people using the ferry on a daily basis is going to be the daily tolls divided by the number, cost per day, 2,900. All right. Next, we say if the $1,800 cost, and I'm reading right to the left of my mouse here, part B. If the $1,800 cost is entirely fixed, how much must each passenger be charged for the toll process to break even? And how much must each passenger be charged for the toll process to make a profit of $250? All right, well, to do the break even, we need to take the daily cost, which was equal to $1,800, and divided by the passengers per day, which we already calculated above, is 2,900, so I'll just reference that cell. So the break-even price has to be 62 cents. Okay, then if we want to look at this next one, let me slide a little bit. The daily cost is still $1,800. The desired profit now is $250, so we add that to come up with a total, and then we will divide by the passengers per day. And again, the passengers per day is going to be the same. Since I wrote it there, I'll just reference it from there. And now the break-even price jumps from 62 cents to 71 cents, assuming we wanted a desired profit of $250. Okay, let's take a look at part C, which I'll read it here. Assume that only 80% of the $1,800 is fixed and the remainder varies by passenger. If the toll is raised to 60 cents per person, passenger volume is expected to fall by 10%. If the toll is raised and volume falls, will the county be better or worse off than it currently is, and by what amount? All right, well, what do we know? That if the $1,800 is 80%, then the daily variable cost is 20%, right? So 20% times $1,800 is $360. And now we need to divide by the passengers per day. Again, the 2,900 we've already used. We come up with a variable cost per passenger of 12.4 cents, right? So now let's look at the next to answer the remainder. Revenue at the current level is equal to the $14.50 given right above my mouse up top. I'll type that in. And the revenue, if the toll is raised, jumps to a different number. It jumps to, what was it, 2,900. What did they tell us here? The toll is raised to 60 cents per person, so 2,900 times 60 cents, 0.6. I got 2 equals in there. Hopefully it solved it for me. And then we know that revenue is going to fall by 10%. So we could multiply it times 1 minus 10%, but I'll just do that in my head as 90%. And so revenue, if the toll is raised, will jump to 60 cents, but revenue will fall by 10%. So we get 1,556. Now we back off the variable cost. And the variable cost here is going to be equal to the 2,900 times 90% times the 12.4. So we have the passenger per day, but only 90% are going to be taking it now. So that will drop down our numbers to 2,610 passengers. And then we multiply that times our variable cost. So we come up with 323.64. a contribution margin of $1,242.36. And I think they told us that the fixed cost was going to be equal to 80% of the $1,800. So we'll take the, actually, why don't I just drop in the 80% here. And the template was programmed to multiply 80% times the 1,800 given right there, and also right above my mouse there in the problem. And so if we multiply that across, now we just drop in what it was currently. So current we'd lose 350, the new one we'd lose 197.64. So the county would be better off by the difference between those two numbers. Okay. Now, question D says, assume that only 80% of the 18 is fixed and the remainder varies by passenger. All right, now what we're going to see is revenue is still going to be the same amount. I'm sorry. All right, now we've got a little bit of difference here. Let's increase the toll to 70 cents with a 5% decline in use. So the original revenue is $2,900. We slide back down. Okay, so now what that is the 2,900. Cell F37 is the 2,900 passengers. And we're only going to multiply that times 95%, and then multiply that times 70 cents. Okay, so I've got 1928 is my revenue. The variable cost is going to be equal to that, the 2,900 passengers. Let me just hit that. It's going to say wrong for a minute here. That's my 2,900 passengers times 95%. We're going to see the passengers drop down to 27.55. And then multiply that times the variable cost. The variable cost we calculated earlier at 0.124. I slide up, all of that went in there correctly. We've got a contribution of $15.86. Now, fixed cost, we've already calculated was 80% of the 1,800, so I'll just pull it from above. And now we're in net profit range. Okay? He says, discuss the saying, we may be showing a loss, but we can make it up in volume. Well, this is the idea that says, increasing volume will help profitability, but only if the volume change increases the contribution margin. Because an increase in volume can often be achieved only with a decrease in price, right? We're talking about the laws of supply and demand. The change in contribution may be negative rather than positive, and we'll leave it to a managerial economics course to talk about price elasticity, which really discuss the impact on profits of a change in price. And that takes care of this problem, everyone.